Hi, this is Srimar, your partner in mathematics and statistics. Welcome to my Factorific channel. First, I would like to thank all those who subscribe into my channel. And second, I would like to thank also those who are continuously viewing my channel, my different videos that would help them understand better statistics and mathematics. At this moment, I'm going to discuss with you the derivation of quadratic formula through completing the square. By the way, for those who are new here, please subscribe, please like and share my videos so that others may also learn like you. And for those who are already here, you just continue watching my videos and I promise you to give you more videos soon. Thank you. So first we have to express the quadratic equation into the standard form. And we call this as the standard form of quadratic equation, which is ax squared plus bx plus c equals 0, where a is not equal to 0. So we restrict our a to 0 because when a is equal to 0, then we will have a linear equation. And our concept is about quadratic equation, okay? So by completing the square, we can derive our quadratic formula. First is we have to get rid of our numerical coefficient in the first term of the trinomial. Okay, so we have to multiply the multiplicative inverse of a, or we divide a to both sides of, or to each term in the equation. Okay, just to remove or eliminate our a, especially when a is not equal to 1. So we have ax squared. We are going to rewrite it plus bx plus c equals 0. And we multiply or divide a to each term in the equation. So we have divided by a here. Okay. And we have x squared plus b over a x plus c over a is equal to 0. Okay. So our last term, we assume that our last term is not a perfect square and it does not make this terms a perfect square trinomial. So we eliminate this by moving it to the other side of the equation. And in doing so, we have to change the sign of our constant term here. So we have x squared plus b over ax is equal to, from positive c over a, and we move it to the other side, it became negative c over a. Okay, now the third term in this expression is missing. So to complete our trinomial and make it a perfect square trinomial, we have to get the third term in which it must be a perfect square, and it is a term that makes the trinomial a perfect square trinomial. So how do we do that? We have this one, we have x squared plus b over a times x plus, okay? So as a rule in completing the square, we have to consider the numerical coefficient of this term, the middle term, and multiply it by 1/2 and square the result. So we have b over a, and we multiply it by 1/2 and square the result. Since this quantity is added here, then we have to add also the same quantity to the other side to make the original equation, or to preserve the meaning of the original equation. So negative c over a plus b over a times 1 over 2 squared. Okay, so adding the same quantity to both sides of the equation will not change the meaning of the original equation. Next, we have x squared plus b over a x. B times 1 is b, squared is b squared, a times 2 is 2a, squared is 4a squared, equals negative c over a plus b squared over 4a squared. Next, we have factoring. So notice that these three terms now is a perfect square trinomial. And the factors of a perfect square trinomial must be square of a binomial. Okay, so the factors must be x plus b over 2a quantity squared. That must be the factors of this perfect square trinomial here. Okay, is equal to, since our two fractions here are not similar, then we have to consider the least common denominator, which is 4a squared. And we divide the LCD by each of the denominators of these two fractions. So we have 4a squared divided by a is 4a times negative c is negative 4ac plus 4a squared divided by 4a squared here is 1 times b squared is b squared. Okay, now our main purpose here is to show the quadratic formula or derive the quadratic formula, or we derive the value of x in terms of the coefficients a, b, c. So that means that the left side of the equation should have a single x, okay, contains the variable x, and the other side of the equation contains our values of a, b, and c, which are elements of real numbers, okay? So our problem now is our exponent, which is 2 here. So how do we eliminate our exponent here? Okay, so to eliminate this, we have to raise both sides of the equation by the multiplicative inverse of this exponent, which is 1/2. So we have x plus b over 2a, quantity to the second power, raised to 1/2 is equal to negative 4ac plus b squared over 4a squared, quantity raised to 1/2. Okay, so we raise both sides of the equation by 1/2, so nothing changed. So multiply our exponent to exponent. We have 2 times 1/2 is equal to 1. And therefore, we have the final answer here, or the simplest form is x plus b over 2a is equal to, our exponent here is 1/2, and it is a rational exponent. And this exponent can be transformed into a radical form. Okay, so this is our index, and this is our exponent in our radicand. So we have the square root of negative 4ac plus b squared over 4a squared. And we have here plus and minus because the square root of a perfect square is either a positive or a negative real number. Okay. Next. Again, we move this one to the other side, and in doing so, we have to change the sign of this into negative. So we have x is equal to negative b over 2a plus minus, okay, the square root of b squared. So we have to arrange b squared minus 4ac all over the square root of 4a squared. So here is, we just use the law of radical, which is quotient. Okay, the quotient rule under radical, which is the square root of b squared minus 4ac over the square root of 4a squared. And we have negative b over 2a plus minus. So since our radicand here cannot be extracted, the roots cannot be extracted, so we retain the square root of b squared minus 4ac, and the square root of 4 squared is 2a, the square root of 4 is 2, and the square root of a squared is a, so we have 2a. Observe that the denominator of these two fractions, okay, is the same. So we have to put the numerators under one denominator. So we have our 2a here, okay, and we copy negative b plus minus the square root of b squared minus 4ac, okay, or we may say that x sub 1 is equal to negative b plus the square root of b squared minus 4ac over 2a. And x sub 2 could be negative b minus the square root of b squared minus 4ac all over 2a. Okay, but the quadratic formula is expressed in the form of x is equal to negative b plus minus the square root of b squared minus 4ac over 2a. That is our quadratic formula. Okay, so I have shown you how the quadratic formula is being derived using the quadratic or using the completing the square. Okay. Thank you very much for listening, and thank you also for viewing my videos.